Alright, so let's talk a little bit about z-scores, because that seems to be a little bit of confusion. So I'm going to go over this one more time, maybe just in layman's terms, and see how we do. Alright, so anyway, here's the normal curve, otherwise known as the bell-shaped curve. And this is the empirical rule, which most of you guys have gotten a good handle on. We talked about the 68, the 95, and the 99.7, and the standard deviations. So again, when the standard deviations are positive, that means you are past the mean. Again, remember the mean is the big one in the middle. Always has a standard deviation of 0. If you go negative, you're going less than the mean. So when you're talking about probability, or you're talking about, our probability or area under the curve, this is supposed to equal 1, the whole thing. Sort of like, again, when I talked about picking aces, when I said what's your chances of picking an ace out of 4 aces? And then the answer was 4 out of 4, which is 1. So all the probabilities here are all in here, underneath this curve, and it totals only 1. So basically every single score that's in here has been assigned to a probability, and that's been done by calculus. So what you're really looking at is, again, if you get a z-score of 0, okay, that means you're on the mean. And that would make sense, because if our formula was, or is, x minus the mean divided by a standard deviation, if this top number, the only way the z is going to come out to be 0, right, is if 0 is on the top. And the only way the 0 is on the top is if the data point that we're talking about is actually the mean. So you're not going to get a z-score of 0, because who would do that? Who would go find the mean's z-score? That doesn't make any sense. So what you have to, let me erase this for a second, we don't need all this. So, come on, rewind. Alright, so then when we talk about z-score of 1, a z-score of 2, a z-score of 3, when we talk about being 1 standard deviation away from the mean, since we're not saying which direction, you have to say 68%, because that's within 1 standard deviation of the mean. 98 would be 2 standard deviations from the mean, and 99.7 would be 3. And then, of course, you have these little tail ends here that are a little past 3, but we talked about this. This is like 0.15 on each corner, so it's not a lot. So how do you do all this with z-scores? Well, z-scores have to do with what happens when the data falls between these numbers. Oops. So if you had something that fell in here and you couldn't tell, like 1.5 you can tell, but it's like 1.6 or 1.2 or 1.3 or negative 2.1, you can't figure that out. So the z-score chart is what's computed all of this for us. So if you follow the formula, and I'm going to talk about just z-scores. If your z comes out to be 1.67, that's almost 2 standard deviations away. Now remember, when you're doing positive, it's not both, it's basically from here, from this tail end, all the way to 1.67. So when they give you probability, when you go look up the z on the z-tables in a minute, what it's calculating is from here, all of this area basically, until you get to about, it looks like to be a 1.6 is like right in about there. That's 1.6. So it's computing all of this probability between all the way down here and all the way to 1.6. If you have a z-score, and again, let me erase this real quick. Okay, if you, I keep hitting there. If you had a z-score that was in the negatives, let's say negative 2.1, let's say you got 1, 2, we'll be even fancier. That 2.12, negative 2.12 is like right here. If you notice, that's from here all the way, and all the probabilities till you get to this section here. So that's a tiny little amount. Alright, so when you're a negative z-score, you are smaller than 50%, because remember, when you hit the mean, you're at 50% because you're half. This is half of it. This is the bottom 50 and this is the top 50. So when you're at negative 2.12, you're down in here. When you're in positive 2 point something or whatever, you're way up here. You're a high percentage. Okay? So since we can't possibly come up with every single decimal z-score ourselves, we have a table. And that's what, let's see if I can bring this up. That's what this thing is for. So this calculates and all the z-scores that you can possibly get from all the different decimals. And this is the negative side. And again, the reason why these are all negatives is because you haven't, remember, here's the mean. You haven't reached the mean, so all of these standard deviations are all negatives. That's why these are all negatives all the way until you get to the bottom. And if you notice, when you get all the way to the bottom, and notice that these are all very, very small probabilities. There's not, these are like really, I mean, they're pretty small. If you get all the way down to when you're getting closer and closer and closer to the mean, you notice when I hit the mean, negative, and the reason why they have negative 0.0 is because remember you can put tenths and hundredths in here, so that's why they have that there. But look what happens when you hit a standard deviation of 0. That's 0.5. We knew that. That's the mean. Let's say I go on the positive side. So here I've traveled all on the negative. All the negative standard deviations. Those are all before you get to the mean. So all of these percentages are less than 50%. That's why they're on this page. There's not a single decimal that's bigger than 0.5. Now, when you get past the mean, which is the other side of the paper, this is when all your standard deviations are past the mean, and that's what this picture is showing. But they want to remind you that the probabilities that you see here start from the left and go all the way to where your z-score stops. Okay, and all of these are positive, and if you notice, the smallest z-score on this table is 0.5, and it goes all the way up to, it goes all the way up to 99.998. So this is almost 100%, and that's at 3.4 standard deviations. That's like 3.5 standard deviations, and most of what we did was 3, and then we had like a tail. Remember, we had like a tiny little tail end. This goes all the way up to 0.99998. You don't have to figure out these probabilities or area in the curve, either way. These are figured out for you. That's why we have the charts. This is all done by calculus. In fact, I don't even know how to do it with calculus because I don't think I ever had to compute the z-score. That I can remember. Anyway. So, when they ask you about things about z-scores being less than or greater than or whatever, when they're asking for less than, it has nothing to do with whether the sign is positive or negative. It has to do with the curve itself. So let's go back to my picture. So if I were going to work on this, and again I was at negative 2.12, I would look up, let me go look up that while we're looking at it, since I have the example. Negative 2.12. So I go up to here and I go negative 2.12 is this one right here, 0.0170. 0170. So this is equivalent to 0170. Okay, again, if you move the decimal point, you're at 1.7%. That's a small amount. We knew that going into this, as this was going to be a small amount. But when they ask you things like when the z-score is equal to that, you say this, or if it's less than or equal to negative 2.12, you also say that, because that's what it's actually computing. So a score that's at negative 2.12 is the same thing as any score that falls in from that score all the way down to basically 0. Z-score, anything less than or equal to this will get this decimal place. Okay? Now, if you have a z-score that's greater than that, then they're not looking for this tiny little piece. They are looking for all of this. Well, the z-tables only give you the tiny little amount. So it's sort of like the shaded area problem. So if I want all of this red and not this blue, I have to do 1 minus the 0.0170. So that's going to, I don't really want to put this down here now, but if it's less than, you have to do this with your calculations, which comes out to be a 0.982. think? That's a 98. So that's saying that you have a 98% chance that your score is going to fall in here if you're looking for scores that are above because it's greater than that z-score. Okay, so that's what z-scores are all about. And really, again, z-scores are just standard deviations, but they're in between standard deviations. You know, like they're not these key ones up here at the top. They're in between, like negative 2.12 is like right in here. So it's in between these key ones, because the key ones we know. That's what we use an empirical rule for, and we add up our percentages just like you took your last quiz. That's what we're doing here. But anything in between, you have to do use the z-tables. So if I said to you you had a mean of 50, okay, and you had a standard deviation of, I don't know, I'm making this up, 7. Okay, and I want to know what's going on with 60, the score 60. How am I going to use all this? So I'm going to take 60, and the question will say, what's the probability of the score being greater than 60? Let's say greater than 60. So I'm going to take 60, subtract 50, and then divide it by 7. So if I do that, I get 10 divided by 7, which is, and again, since 60 is over the mean, I should get a positive number, and I do. It's 1.3/7. I don't have a calculator in front of me. Yes, I do. 10/7 is 1.43. Okay, so this is 1.43. Now, that's a z-score of 1.43. So I go to my chart, wherever the heck I put it, 1.43. 1.43 is in the positives, and we knew that because we're past the mean, which is what this picture shows. 1.43 is 90.9236. 0.923. Whoops. Where am I? Where am I? Oh, here. Would be 0.9236 if this were less than, because that's what it calculates. But because I'm doing greater than, I have to subtract that from it. But only if it's less than. If they, greater than. If they ask you anything else, then you take exactly what the value says. So key things to remember is if you hear higher, greater than, you see that in anything, that's all 1 minus whatever the z-score says. 1 minus z-score. And that's the I should say the z-score probability. You know, the decimal part. I don't know if I spelled that right because it's late. Okay, if you have less than, lower, or less than or equal to, actually I didn't say greater than equal to, less than or equal to, then this is when you take the actual z-score probability, which is the decimal. Okay, so the decimal we would straight out come out with. So what's nice is, since you know a little bit about standard deviations, it's a little bit easier because you know if you come out, if your number you're starting with is bigger than the mean, you know you're going to get a positive number. If the number you start out with is less than the mean, so like if I tested 40 instead of 60, I would know I'd get in the negatives, and then the negatives are on this side, and that means I'm going to get a small percentage. Small percentages here, and they get larger as you move up. Remember, your z-tables are only good from the left all the way. Oh yeah, and that was the other thing I meant to say. Another thing is, it says, sometimes it'll say, what are the probability or area under the curve that's right of the z-score? That these are all meaning the same thing. Or this said left. Left is less. This is actually whatever you get for the z-score probability. So less than, lower, less than or equal to are left. The area to the left. Area under the curve and probability mean the same thing. Area, oh gosh, it's late. Under the curve and equals the probability. Wow. Probability P-R-O-B-A. Okay, so that means the same thing. Okay, I hope that helped. So if not, then I guess I'll work with you tomorrow on it.